Okay, so hello everyone and welcome to the session. Om will be taking it. Om is an 11th grader from Karad. He qualified, he's an INMO from this year, and he was also a bronze medalist from APMO. And he is very good at geometry. Um,
Good.
I will refrain from saying more. Om, over to you.
Yeah. Okay. Hello, guys. So, yeah, I guess everyone is like fine with geometry. And yeah, today's we will like cover some like different type of lecture. Rather than any special topic, we will like covering construction in geometry. So, like each time we don't actually like few times we actually have to construct new point and which also make problem like not easy but like easier solving something like that. So yeah, and yeah, I guess like feel free to speak up. Uh, if you have any doubt about geometry or something, you can like ask now or at the end of the lecture. I can like yeah answer it. Yeah. Okay, so I guess we will start now. Uh, can you guys see my screen?
Yeah.
Yeah. Okay. Yes. Okay. So yeah, today's class, as you like from the topic name. It will be about like construction viewpoint. So like many times you have like just a the question just give you the basic information about geometry, and many times you like have to construct some new point or which is lot seems lot like magic, but once you get an intuition of geometry, you will like feel free like feel it's not that much hard. So like yeah, like we will covering nice problems today. Just to note, if like some of like people have like seen the problem, I will give few like buffer problem or something, and you guys can try that in meantime, so that like no one like is free. Yeah, so like if some of you have like seen the problem I'm covering, then you can just take a screenshot now and just do these problems. Yeah, okay. So let's start with first problem. Yeah, and yeah, I will like generally tell you how like also how you can like target the geometry problems, how like you thinking process when you solving the problem goes on. So like yeah, so first problem is here. I will give few minutes to like think about. Yeah, if you guys have like any idea, like any however low or however high it is, like just feel free to speak up. Yeah. Yes. Cameras turn off, but okay. Yeah. So okay, let me draw the diagram. Uh, my diagrams are not that good. But yes. Okay. So what problem statement is saying us is like AB is equal to AC, and we have some point X and Y on uh, like X on PB and some point Y on PC such that if M is a midpoint, let me draw it. Yeah. If M is a midpoint, then we have this angle equal to this angle. Now, okay, so what are your ideas? Like we have some two different points, some random points, and we have also P is a random, and we have some different angle conditions. And we have to prove like P, A, X, Y, Z. Any ideas? Not a solution, but like any construction or some like some extend line or consider this or some something you have. Hmm. Okay, let's the chat. Okay, join AY. Okay, yeah, that's actually like natural idea. So like okay, so we have to prove PAXY cyclic, and so like it's obvious. Can we prove like XAY equal to XAP? Like, but okay, so like how can you think of like this angle? So the angle XAY is like weird. So can we do something else? Or like how can we do go from there here?
Construct a parallelogram
Where? Okay.
like XA and a point,
XA
Y and the fourth point.
like this. Okay. Yeah, but so we get some like A dash suppose, but how we like process like proceed. So like there are like one step like we have to also use the angle condition BXM and MY. So like in the whole like problem we also have to like use each condition like AB equal to BC the parallel thing and this. They cannot use equally like together but each step by step. Hmm. Consider intersection of x and yeah. Okay, that's actually nice idea. We will like make it a bit easy to make. See. So suppose we construct this. Suppose this is S and this is T. Then can you guys see any cyclic coordinate? I guess yes, someone mentioned. Yeah. So we get like
What were your
T.
constructions?
Construction is like okay, yeah. We extend XM to meet PY at S
Okay.
and ym to meet px at t, and now we have some syt equal to txm, which is txs. So like this angle is like equal to
Okay.
this angle.
Then like T is
Yeah, we extend, so they are like collinear.
uh-huh. Yeah.
So we get xy is t cyclic. Yeah. Huh. But still, okay, we get s and t. Then how we will do? So now we will do some magic actually. So, okay, so what we have to prove? We have to prove Pxy, what a good circle. As in this is circle, and yeah. So we have to prove Pxy is cyclic. And yeah. So what are like some ideas you can think in this direction? Like okay. So we have like M is midpoint of BC. And we have some two weird angle conditions. So like it's somehow like useful to construct the sum calculator. Okay. Uh, R X Y. What BRXY can? Okay. Take R equal to intersection of. Okay, there is one more nice idea. Okay, so there is one more idea. We can construct the perpendicular center of the circle. So like this is like parallel, so this perpendicular bisector also perpendicular to BC. But actually, how like you will deal with? Suppose we have some center, then it will like more weird point. Even like S and T like not looks nice right now. By construction. Okay, there's one more idea. Okay, someone like come with some intuition that like BCXY can be cyclic. Okay, it can, But okay, sometimes there's also in like geometry problem solving. Suppose we have BCXY cycle. Then what we will get? Like this angle equal to this angle. And because it's parallel, like BC is parallel to PA, we get this angle. But huh. Okay, so can we prove this? Yeah, interesting.
No,
Nice.
because we need to prove AYX is equal to that angle, right?
Yeah, yes. That's the point. That's why like it's not. So sometimes we also have to like claim some things are not. Okay, so let me give the idea because it's like little bit hard to come up. Show ST is yeah. Okay, ST parallel to BC. Uh, okay, so like I don't think it is, but yeah, we can work on that. Okay, so let me like give some magic point. So we have this angle conditions. Now, one way we think about it is like cyclic chord, but now we have to think about something else. So what we do, we extend AM, okay, and now we take some point Q, such that this angle BXM equal to angle BQM. Okay, now what is like what is AM? It's like perpendicular bisector of BC, right? So what we have other thing? Do you guys can see something else?
Yes, it will,
Oh,
on the other
yes,
side also it will be the same angle because it's the perpendicular bisector. And so the
yes,
other one will also be concyclic.
yes. So like we have BC here and M is here, and as a M is like midpoint by like because this is perpendicular
These two
bisector.
triangles are congruent.
Yeah, these two angles are congruent, and that's why these angles are equal. So
Yeah.
like it's depends like we know the property any point on like perpendicular bisector have like subtle equal angles. So what angle we should take this? Like what should this angle equal? Like it's like obviously we will take this angle. So like
Yeah.
we construct Q such that BXM equal to angle BQM. Okay, now can you guys see something? What can you like observe?
ABQC is concyclic.
ABQC. How is it? No, it's not consecutive, but like go lower, like something less. Okay. We have okay.
BMQ and CMQY are consecutive.
Yes. So let me choose a different thing. So we'll have AMQX and MQCY cycling.
So power of point A with respect to those two circles is same.
Yes, that's also useful. So, okay, let me explain why. So, like we get this angle is equal to this angle. That's a BXMQ cyclic. And because of perpendicular bisector, we have this angle also equal to this, which is also equal to this angle. So, we get two cyclic coordinate. And because of radical axis, like both intersect at MQ, A lie on radical axis. Now, that also can useful. But yeah, someone has mentioned, we know this is perpendicular and this is cyclic. So we get this is 90 and this is also 90. So can you guys see something else now? We have like BXQ equal to angle
Even
C.
Q is cyclic. PAQX.
Yes. Yeah, so like because some of these angles PXQ and PYQ is 180, we get PXQY cyclic. Everyone understand?
Yeah. And we can finish off because PAQX also is cyclic.
Yes. Now see, like because AP is parallel to BC and this is 90 degree, we get this is also 90 degree. And so we have like angle PAQ, which is also equal to 90, which is also equal to angle PYQ. So we get APXYQ cycle. So everyone understand the solution? Or should I repeat once?
Yeah,
Okay.
it's fine.
Yeah. So what was okay? Yeah, okay, more explain. Yes. So the motivation is like okay, so we know the fact like every point on perpendicular bisector, we have some few nice things with it. So like suppose we have something like this. So we know these are equal, these angles are equal, and also these angles are equal. So like because we have some two weird angles and we have to like construct some new point. So yeah, so like it's a one more thing. So now we have to prove P a x y cycle. So it can always like happens we cannot prove a direct angle change. So suppose like if we have some 4 points to prove on cyclic, we always take some weird x point, like new point, and we prove this for our cyclic and this for our cyclic, or something like that, which is like lot more easier than proving direct. So yeah, that's why like we have to construct some new point. And the thing is by like remember this property like every point on perpendicular bisector subtends like equal angle. We take some point. We take point q. So like each time if you see something like some two weird angles are there, you can always like consider perpendicular bisector and suppose they are equal and you can consider like this. And you can get some next diagram like this from there. Yeah. So like now if you each time you get something new like this weird angles, you can always consider construction some new point. There is a yeah there is also one more thing I like just to side note. So suppose you have some two different weird angles and they are equal, and not always you have perpendicular bisector, but if you guys consider the yeah suppose we have some point P here. So we consider circle of BPQR and PSQR. And no, actually, oh sorry, no, we actually not take P. We just consider circle of this. Ah, okay, okay, fine. I guess this is not needed. Okay, I guess I'll show example more properly. But yeah, so everyone understand this question and solution and motivation. Important. Okay. So yeah, so now let's move on some easy or hard problem. What you guys want? Let's go for some hard problem. So now we again have one more construction problem. So like obviously now class is about construction. We will do construction. Huh. So try this problem. I will give few more minutes. And each point, if you have like how you construct, like how the motivation goes, or something else you didn't understand, just ask. I can repeat you. Mhm. Okay, let me draw a diagram. So we have angle bisector. It's okay, fine. I will like wait. Just look at ABC. Okay, let me complete. diagram. Okay, anyone have any idea? So like first thing rather than like construction you can do is like change some angles. So like can you see some angles? Sometimes we have to calculate. Okay, if someone not hmm. So what we have is like D is a feet of like angle bisector. So this angle equal to this angle. Then we have M midpoint of BC or circumcenter, and E is like deflection. So like weird point. And we have some XY more weird. And we have to prove they are cyclic. How can we do this? So do you know anything about like AD and related to M, OM? So like if I consider this point L, do you guys know anything about L?
LB equals LC equals LI.
Yes. Or in other word, ABLI cyclic, ABBC and L is cyclic. This is like in center lemma or something. So like if I is the in center of ABC, we have Li equal to LC equal to LB, where L is the intersection of angle bisector with circumference. And because BL equal to LC, L also lie on perpendicular bisector of OM. Okay, so like we have L now, but what can we do now? So we have some weird point E. So what guys you can think of like M is like midpoint of DE also. So what can you what like
L is the midpoint of dy.
yes, it's midpoint of DY.
Yeah. And therefore
So
y is the excenter.
why is X in? No, it's
No, right. Yeah,
yeah,
it's not. It's not.
it's not. But you have something now like L is midpoint of DY
Yeah.
and EY is perpendicular to BC.
Is it like circumcenter?
Yes. So because it's midpoint, we have this thing. So like because this is 90, we know the circumcenter of why
Right angle
okay,
triangle.
why is not X center? Because if you consider X center J, IJ's midpoint is L and DY's midpoint is L. So J is
Yeah,
like
right.
and yeah. So why is like reflection of D actually not I.
Yeah.
So now, yes. So we have this because of like 90-degree, we know like circumcenter of 90-degree triangle lie on like dy only, and which is L. So we get LD,
Why
LD.
is DM equal to ME equal to DL equal to LY? Like,
Okay, so this is 90. So that's why L is midpoint of dy by midpoint theorem. And now you can do like angle change. So like
no,
if this
no,
is
no, no, no. Like, why is DM equal to DL? Isn't the blue thing and black thing different?
yeah, that's what I'm saying. Like because like it's this equal to this. Like L is like circumcenter. So one way, other way to think is like M is perpendicular bisector of D again. So like LD equal to LE, and we prove that LD equal to LY. So like L is circumcenter. Do you get it? Uh,
Yes. No,
yeah.
but like I was asking ki Why is DM equal to DL? Like, aren't they different? Or like maybe you just
dm equal to
They are not equal, I guess.
yeah,
nah,
they're not.
yeah,
Then
yeah, they are not.
uh,
We just given dm equal to m.
Yeah.
I can like yeah. Show the question. Okay, x is a in touch point also. No, yeah, no, it's not because it should like in touch point of uh in center. So like if it is like AD or AI something, so the reflection of AI is X touch point, not D. Yeah. Okay. Okay. They are nice ideas. Just like so, think about it. What can it be more? So we have something nice about L. Hmm. Okay. There's one more idea. XY is like diameter of BC. Yeah. So we also have to like think in that direction. So what do you guys think like about this circle? So actually, I will not draw the circle, just consider because my diagram. But yeah. So in previous problem, we like I told like each time we have to think some different point on circle, not just 4 point. Yeah, not just 4 point. So can you think of anything different? Some new point.
Maybe the
And
center.
in center. Oh, okay. Hmm.
It
But
looks like it could.
but we know that like the BIC pass through J also. But then yeah, it will not. No. Yeah, but nice idea. The right angle make me think extend y. Okay, that's yeah. So suppose we extend this the point x m e. Okay, uh, no, you are right in the right direction, but little bit more precise. So someone come up with like because we have this 90, can we construct something like this 90 or something like that? It's not exactly that, but think of in like that direction. We have this is also perpendicular, this is also parallel. So can you think of something? If we introduce it, yes, yes. Okay, not reflection of O, but someone like come up with very nice idea. Let us see. Okay,
A reflection of X.
yes. Not X actually. We can like name it something different.
E, like reflection of E, I guess.
Yeah. So we construct reflection of E above L. So we have this side, and this side equals. And now, okay, I just draw, but can you prove XDZ collinear? Can you guys see how? So we construct reflection of E.
Yes.
Yes, because yeah, that is also nice point. So okay, let me say this. So like because we have L is like these two triangles are like what you call congruent. So that's why we have this is also 9. And because XD is perpendicular to BC, we get XDZ collinear. Now one more thing we have now is like this is parallel because this is like yeah, this is literally square right now. So we have BC parallel to ZY. And so can you guys see? So because of that, can you guys comment
The
on like
trapezium.
yes, they are cyclic. So because B, C, Y, Z are like isosceles trapezium and isosceles trapezium is cyclic. Because like this angle theta, this will 90 minus theta, 180 minus theta, this will also 180 minus theta. And they are isosceles trapezium because BC parallel to ZY and this like this is reflection about M, like perpendicular bisector, literal. So now, okay, so fine, we construct some new points Z, and now we just left with proving X, B, C, Z cycle. So how can you guys prove this?
It's if we just prove that M is the center of the circle of BXC, then MX is equal to XZ because Z is just a
Yeah.
reflection.
Yes. Yeah.
We just need to prove that because we already know BM equals MC, then the same thing has to be MX.
Yes, but thing is, we don't know like MC equal to MY, right? And BY also, sorry, BC also lie on that circle. So like the thing is, the center of this circle lie on perpendicular bisector of BC, like lie on OM, but it's not M or it cannot, like we are not sure about
We can easily show that XC equals CZ.
XC equals CZ.
Because XD equals DZ.
Why?
Z will also turn out to be the reflection of X-ray.
No, no, no. Wait. I don't think so. No, it will not actually, I guess. No, like we cannot like directly say this. Like, okay, the reflection thing we do here was like proper because like M is like midpoint. We given E as a reflection of D, so we construct Z as a reflection of Y, and we get that cyclicity. But X is not like the same thing. Okay, now I guess we have to do some different thing. So we actually not like use what is like AO. So like for property of X, and we have to use everything together. So what can you think about X? Yeah. So what can you think like X lie on OI? So do you guys know anything about AO? Okay. Uh, let me tell like one nice fact, which is like you sometimes very useful. If you consider like theta perpendicular from like A to BC, so wait, AX equal to DX. Yes, how? How you do this? Okay, so let me so like if you consider this line theta altitude, we get this angle equal to this angle. This is like angle chase. So like if you consider this is like A minus half minus like 90 minus B. And the other thing here is also like same because like we know angle OAC is 90 minus B. And so like what, yeah, I guess there's no need to do this. But yeah, so we get this angle equal to this angle. And we know this is like parallel to EY. So we get this angle equal to this angle. And now as someone mentioned right now, we have this angle equal to this angle, which is also equal to this angle, which is also equal to this angle. And as we prove this is collinear, we get this. So we have so many equal angles. And because of this angle chase, we get AX equal to XD. Everyone understand why AX equal to XD? Or like the angle change. Angle change is like important part. Okay. Now can you see some cyclic coordinate involving X? Can you repeat? Okay, yeah. So we have actually like in short, we have some angle DAO, which is actually this. By same like angle change, we get its okay angle. Okay, yeah. So this is well known like thing. Like if you consider theta of altitude and AO, which is like all circumcenter and A, the perpendicular, like angle bisector also bisect that lines. So yeah, so angle DAO is actually equal to angle DYE, and which is by like symmetry or like its square, we get it's a DZE, which is also equal to, yeah, that's enough actually. Yes. So can you guys see from this angle shape? Like,
We can also directly compute, right, for what it's worth. Like we
yeah,
can,
yeah, we can actually directly compute, but yeah,
ADX is 90 minus ADB and
yes.
ADB.
Yeah, okay. So I guess people got the idea. So what we have is like angle XZ equal to angle XZL. What XZL? So like this angle is equal to this angle, because like, yeah, by equal angle. So we get something like, yeah, something like, wait, let me write down here. Can you guys see my screen? Yeah, okay. Yeah, we get AXLZ cyclic. Everyone understand why AXLZ cyclic? Yeah, now POP, yeah. So like now we have some cyclic quadrilateral, and each of like some intersect at D. So we use now like power of point. So like we have dA into dl, which is equal to dx into dz, because ax dl cyclic, and we have dA into dl is also equal to db into dc, because abcl cyclic, and so we get this, and by this we get bcxz cyclic. And as we prove bc, yeah, we just want to prove that. So okay, I will repeat once. So what we like think, like, okay, because we have some weird point E, which is a reflection about midpoint. Yeah, reflection about midpoint. We think of like this, like L is like, because we have some in center, like we have angle bisector, and we have to think about O. So we introduce L because L have some nice property. L B equal to L C equal to L and few. Then we get this like lengths are equal. So because of the, we like have 90-degree, so we just complete the half of the thing. That's why this is like motivation to construct Z, because like we have LD, LE, LY, and M and D are like, D and E are like reflection about OM. So we are also like motivate to construct Z. After constructing Z, we do some angle chase to get like OAD equal to uh, DZE, DZL, and which is give us like cyclic quadrilateral, and then we use power of point. So everyone understand, or should I repeat something else? Anything? Yes. So
Yeah,
like wait, what?
yeah, understood.
Yes. So do you guys like got a motivation for Z? Because we have E, which is like little bit weird. Uh, yeah, because oh, so yeah, dA into dl equal to dB into dc, because AB CL cyclic. Okay. So yeah, so because we have some weird reflection, we also take reflection about Z, Y, which is Z, and which is we indeed find a nice properties. So we again like see the application like perpendicular bisector on DC and reflection things. So yeah, nah, okay. Yeah, there are like different solutions. We will do them later. Okay, so now, okay, I will tell the source later, but if you guys interested in source, can anyone guess the source? Anyone have any guesses? I mean, I obviously asked, so like it's obvious now. Uh, Wait, I cannot. Give me a second. Okay, the source is like IMO shortlist 12 G4. So like 2012 G4. Now we will do some little bit easy problem. Okay. Let's go for some lemma or something. Oh, 2000 IMO. Oh, don't. Yeah, guys. Secretly, we got this next question. So, what do you guys want to do? Some easy problem or some useful lemma? What are you guys? What are your choices, guys?
So lemma.
Useful lemma. Okay, it is useful. Just the proof is very nice and instructive. So yes, we will prove this lemma today. So let me like just explain the problem. It's not anything about diagram. Okay, so we have ABC. We have point P such that angle ABP equal to angle PCA, and we have point Q such that it's a parallelogram, and we have to prove this angle equal to this angle. Okay, so we have some two weird angle condition, we have some parallelogram, and now we have to prove another angle condition. Yes. Any ideas? Like if you come up with any idea, just say, because this is like not easy actually. So this is like nice lemma, and like proof is not that easy as it seems. It's called first isogonality lemma. Let me just check once. Yeah, it's called first isogonality lemma. Why we are done this? Yeah, take some time. And which is like quite useful sometimes. I have seen many applications. Okay. So what do you guys like think? What is like parallelogram? Like we have one parallelogram. Okay. Oh, moving point. No, we like not too easy solution. We want little bit hard, so we're not using moving point. Yes. Yeah, you can speak up. I don't have. Uh, PQ pass through M. Yes. Behro, I guess you can speak up. Yeah. P is a no. P is any random point. I mean, not too random, but like inside the ABC. Any point inside the ABC. And also have to follow this property, of course. Oh, wait. I just come up. What are the locus of P? Huh. Okay, I never thought of it. seems to be some kind of like hypo. But yeah, okay. So yeah, someone mentioned PQ past the midpoint of BC because we have parallelogram. Now, what do you guys think of this angle prediction? Reflect Q. Okay, that's a nice thing, but okay, what after reflection of Q? So get this angle equal to this angle. Angle yes, so like someone just said reflect Q about BC and we get BPQC cyclic, yes. But yeah, now there can be like solution along these lines. We can actually find now. Okay, so let me like tell you because the reflection P. Okay, where will it be? Okay, yeah, there, this is true that like the reflection of a perpendicular bisector of P is Q dash. But of course, I'm not taking all problems of perpendicular bisector. So think of something different. The construction is like little bit hard to come. Okay, we construct like now P dash also because only like Q is like not good like partiality. So we also get P dash now. Now what to do, guys? And yeah, we have like Q dash and P collinear. We have their cyclic. More, something more.
We should try to prove APB and AQC congruent or similar.
A, which one?
AQC
A,
and
B,
APB.
I don't
A.
think they will be congruent though, because AB cannot equal to AC all the time, right? They must be similar.
Huh. I guess, yeah. So like, they cannot be like always congruent.
Yeah, but
You can,
similarity is a must, I guess.
okay, maybe reflect your angle basic ratio congruent. Okay, that's actually good idea. So wait, and let us like construct some diagrams. So what is this one diagram? So suppose we have another idea. A, B, P here. Now, because we have to prove like, so these are isogonal lines. So like you have to prove AQ and AP are isogonal lines. That's supposed to mean they are like sub reflection about angle bisector. So we construct some point P dash uh, such that this angle equal to this angle. Like we construct we reflect AP about angle bisector. And now we have to prove that P dash lie on AQ. Okay, construct angle bisector and insert. Okay, that's a reasonable idea. But I guess okay, it can work, but okay, I guess I have to like tell the idea because it's not. So we have some parallelogram. Okay, that for that I was waiting for like why no one come up with that. So we have P such that this angle equal to this angle. So like it's obvious we like extend those lines. Okay. And yes, suppose we have some this X and Y. We also have Q here. Now what can I say? So X,
Why
Y,
BCX is concyclic?
cyclic. Yes, concyclic. Now What? What can concisely give us? Yeah. Oh, very good. So we have
So by power of a point, ax times a is c equals ay times ab.
yes. Yeah, that's its PowerPoint. Something more like something in terms of angle. Because like now we have to also deal with Q. We cannot just deal with P. Like
And maybe byc is equal to bxc in terms of angles.
XC by C equal to, yes. So we have this angle equal to this angle. AYX equal to C.
B-
Yeah, that's yeah,
BQ, QBC is also equal to that.
yes, cube is also equal to. And can you see other angle also? So like this angle is equal to this angle, and that's equal to this angle. So what can we say? So PXY is similar to triangle QPC. Okay, now it's little weird. So actually, can you like there are two similar triangles, yeah, like each one have vertex on AC and BC, and they are like different orientation. So like by intuition, like some intuition give us like, okay, so this should be equal. Okay, so here's like little bit rigorous thing about this. So we know if you consider angle bisector, so the reflection of AC is AB because it's angle bisector of BAC. So reflection of AC will be AB. So when we reflect about angle bisector, like reflect everything about angle bisector. So X go to somewhere here X dash, Y go to somewhere here Y dash. And we have some point P dash such that this angle condition still holds because we just reflection. So we get this equal to this and this equal to 2 dash. And now can you guys see something?
Yes. So I think
And one more thing. Someone just mentioned, wait, let me change this. This is angle C. And after reflection, what we get? This is angle C. Yeah. Okay, yes. So we get X dash, Y dash parallel to BC. And so like, and we also have like P X dash Y dash similar to Q BC. So it's like homotherapy from A, which takes XY to BC, also send P dash to Q. So, okay, let me repeat the what I did first. So first we construct point X and Y such that they PP and PC intersect AC and BC at XY. Now by angle change, we get this angle is equal to this, and because of parallelogram, we get this. And similarly, these two angles are equal to this. And now we get this condition, which motivate like they are like similar triangles but in different orientation. And so we always have to like do some construction or like you can think transformation because we have angle bisector. So what we did is like reflect X above angle bisector. And because reflection of AC lie on AB, X will lie on AB somewhere, X dash, Y will lie on AC somewhere, Y dash. And because of also cyclic thing, we get XYBC cyclic. Hence, we also get XZBC, XZY dash parallel to BC. And because we have similar triangles, they are homothetic. So like Q is the indeed on lie on this A dash, AP dash. So if you guys see, we just use your ideas. So like M was midpoint, so we have to think about it. We also have to think about reflection about angle bisector. Their second idea. And third idea was extending the lines. And we just mix up the all three, or like basically these two ideas. So do you guys understand? So like each time we don't come up with like directly solution, the magic didn't happen directly. It takes time, but we just like think about what ideas we have, what construction or what kind of different properties points are like have. So everyone understand the solution and the motivation also. Uh, how did you finish up? Okay, let me explain little bit, guys. So we have P, we extend this to X and this to Y. Then we take reflection of X about angle bisector. So it will be some X dash and okay, some X dash and also some Y dash. And we also reflect P, which will like P dash. Now what we have is like this angle and this angle is equal to like this angle, wait, which is also this angle and this angle. And because XY is parallel to BC, which we get because of this angle is angle B, by reflection we get this angle also B. Angle AXY equal to angle B, which is also equal to angle AX dash Y dash. And hence they are like parallel. So because X dash Y dash is parallel to BC, we get this thing and P dash is like this line. And now because Q also satisfies same property, so they are similar and because of parallel lines, they are actually homothetic. So we take homotheity at A, which sends X dash Y dash to BC, and which also send P dash to Q. And that's why how angle ABX is equal to angle ACY. Because we given the point P's condition. So like the point P is defined like these angles should equal. And that's why we motivate for X and Y. Okay. Now, okay. Now this was like some motivation solution, right? And this is not fun, guys. So we will do something fun now. So we have this P here. We will discussing a lot about this theorem because like it's useful and the construction is very nice. Not nice, but okay. And we have this point Q. Now, just see. We have this parallelogram and we have this side equal to this side. This is parallel to this. So can you guys like motivate for something? Yeah, okay. Let me give you there. We construct R such that ABPR is parallel. Ta-da. Magic point. What now? What you guys have? What is like property of parallelogram? This angle equal to this angle, which is also equal to this angle. So we get ARCP cyclic. Anything more? Yeah, you guys tell me. I will like. I'll give you the point. Now come up with the solution. So we construct R such that APBR is parallelogram. So now can you guys like come up with some properties or observations? Any observation? Any observations, guys?
Take another point S
Okay.
such that BRSC is a parallelogram.
BRSC is parallelogram. Okay. Then okay, how then like tell now? Like someone just said.
Should I tell?
Yeah. Yes.
Okay,
Yes, go.
Angle ABP, suppose say theta. Then according to the question, we also have ACP also theta.
Yes.
But since A, R, P, and B are cyclic, we get that ARP is also theta, yes. So then ARCP is cyclic.
Huh.
Then we will consider angle QAC.
Hmm.
QAC.
Yes, yes. Okay,
And since AR and QC are parallel and equal, we also have AQCR is a parallelogram. So
yes.
angle
Yeah. So like,
QAC.
so wait,
Yes.
so ARCQ is parallelogram because BP is parallel to AR and which is also parallel to QC, and they are also equal. So we get, because you are a parallelogram. Yeah. Now what? Continue.
Then angle QAC would equal ACR.
Angle QAC equal to ACR. No.
Yes,
Ah,
because
yeah, yes, yes.
yeah.
Ah, yes. And now?
Then since ARCP is cyclic, we have
Yeah.
that ACR equals APR.
APR, yes. Nice.
And then
And which is
since
equal to
ABPQ are parallelograms, we have those are equal.
yes. Very nice. Yeah, so that's the proof. So like we just construct point R, and now we have two parallelograms. So like ABPR parallelogram, AQCR parallelogram. So like we have like three parallelograms, each connect to each, like each one connected to each other. And that's why we get, now we just do angle theta. So like, because this is parallelogram, like AQ is parallel to RC, which gives us this angle equal to this angle. And because we get APCR cyclic, we get this angle equal to this angle, what? APR. And because of parallelogram again, PR is parallel to AB, we get this angle. And hence both are cyclic. Yes. So yes. So yeah. So motivation for R. Yes, motivation for R is not like so obvious, but yeah, if we can like argue about motivation, it can be like there is parallelogram in the question already, and so we, okay, so it's like this. I guess I should say that. So suppose we have some conditions given, like first some condition of geometric problem, and now we have to come up with result. So like we have final solution. So what each time we do is like we go do some observation, like some angle change, some obvious radical axis, obvious cyclicity, and we get some like property P or statement P. We also go backwards. So like if we have to prove R, we have to prove this is like isogonal. We go like backward. We think of something else, like about like P dash, and then we just prove P dash and Q are collinear or something like. So we go from like something P to R and A to B, and now we just have to connect P with B. This is like philosophy style. So that's how like we do like geometry problems. Like each time we go from the first given properties to somewhere else, and the thing we have to prove, we go back and then we connect them. Now the thing here is like sometimes this is like easy step, or sometimes we have to do something else. So now right now we construct some new point. That's like the thing of construction. So like we construct some point R, which is like intuitive because like it can obviously, like there should some thing which can make it some less easier or something. And like if I say directly, I can say like, okay, because we have BP equal to QC, we always should consider some point R such that it's also equal to this thing. And so it's like obvious to construct the parallelogram. But yeah, uh, either you can like take a motivation like there's parallelogram, or each time now if you see some new problems, consider some parallelogram or some complex thing, you can always think of some out of the box, like can we construct this R, can we do some angles, can we these are like some different angles, A, BP and A, P, C, Q, can we construct like make them equal or something? Yeah. Yeah, what, Raya?
Still didn't get the motivation behind R.
Okay. There's like not such like motivation really.
Like, how could you like think of it, like, you know, solving this?
Hmm. The the one way to think is like, yeah, actually now once like sometimes you don't like see obvious motivation, but now once you like know this now lemma, you can like use it everywhere. Or the even the proof of this lemma like constructs in some new point R. Uh, if I say like it's not obvious in first look, but I can like we can argue like okay we have some equal things with B and C, and that's why like R like construct some parallelogram. There are like some few constructions like okay for the sake there is another solution which constructs some point M such that APBM is cyclic. Sorry, parallelogram. And now we get this angle, and now we do again some angle chase, and we again get some cyclicity. I don't remember the like exact angle chase, but yeah, you guys can like think of another construction. So like if we have point P, we construct point M such that this is the parallelogram. Now, yeah, and now we can do some similar steps, not too much similar, but yeah, like this is like homework. You guys can think of construction M and now prove the lemma. And the one we did was like constructing R. Yeah, some of the like okay, it's not much motivator. Yeah, it's like yeah, constructing R at opposite. So few of you guys suggested here to construct the reflection thing. So if you guys see, this is like same as that. Like you reflect the point B about R, and now we get nice conditions. Cyclicity. Yes. Do you guys have any other like? I don't know. Is it like enough motivation or like not motivation, but idea is clear, right? The new point.
Yeah, I think the main thing is also like if you have one parallelogram, then you want to create
Yeah.
a combination.
May
You get
or like
three.
even the like we have angle condition which are like weird to different place. We always do some same angle things. So like I can construct some this circle, consider this circle or like consider circle with this angle say, which is like pass to C, and then we do some nice point. Can we find some nice point on this circle or something like that? Yes. Okay. So yeah, if you guys want like where this can useful, I can just for your homework you can try 2012 G2. So like the isogonal lemma is like useful there, and it can you can finish that. So like just try this after the lecture. Craziest construction. Okay, so this is like arguably most crazy construction you can like think of. Like why are you think for parallelogram or something? But there are for not this problem, but there are some weird constructions. Uh, okay, everyone like clear with the solution and anything you didn't understand, like both solutions. Okay, what is okay? Not exam. Sorry, I should say it properly. 2012 ISL like shortlist problem G2. Actually, I can do this. I will give after the lecture, but yeah, you can try this problem after the lecture. It's like on isogonal level. Okay. So next problem. Do you guys? Yeah, let's do some easy problem. Not easy, but you will see more of in this type of. Okay. Yeah. Now I guess you guys try first, and this is like easy. You guys can come up with this. Anyone like have any doubt? Everyone enjoying the lecture, guys. Hello.
Yeah.
Yes, nice. Yeah.
Yes.
And like, yeah, like come up whatever idea you have, like just like send me DM or like speak up. Yeah. Send me DM. Like weird ideas are fine. That's like till now we are just doing weird things, not anything proper. Ah, nice. Yeah. Oh my god. Okay. Because you guys can like come up with solution. What does mean by okay, so let me like construct the I will not draw the diagram. So much construction. New point then. New point. Okay, this is like so much bad diagram, but take it. So what do we have? Meet at P. Then this meet at Q. Okay, so other than C is supposed to mean that. So when we like intersect MC, there are 2 points, C and some point R. And so we not take C, we take R. And now we have to prove A, R, P, Q sec. Has anyone seen this problem before? Other than like, yeah, obvious ones.
See this before somewhere.
But do you know the solution?
Do I have forgot it? Or maybe it was just a simple problem with the same PQ.
Okay. So like there are like kind of problems with like okay, like a triangle, we have like discover many things like circumcenter, orthocenter, they have properties like we have also have what you call quadrilateral and also quadrilateral have this type of thing like BCQ. And so sometimes they are cyclic or not. And we have lots of many theorems about this. I saw it 3 minutes. Okay. Yeah, so we have like lot of many theorems, interesting theorems about this actually. So like some weird theorems like midpoint of these things are collinear and some these like circles are like intersect at one point. So you guys can like think of like just explore the property of this diagram. Okay. But yeah, that's like side note. Let's focus on the question. Yeah, sometimes like you have to like explore the diagram by yourself. Like even the like previous question, you can actually the previous question has so many different proofs. So yeah, you guys can think about it. Okay, we have already uh, hmm, first like construction reflect B about PQ. Okay, let's think about it. So we get B dash. Now what? Now I guess you guys have to come up with solution. You guys tell me how to solve the problem. Okay, this one I will tell. Or yeah. So this angle is equal to this angle.
So those are cyclic.
Yeah. So like this angle also equal to these three angles. Just give me 1 minute. Yeah. So we have this angle equal to this angle, and which is also equal to this angle, and hence we have this side like P Q D P dash, which is a nice like the construction. But can you like how you will relate with A and R now? So like something different. What are the obvious thing you guys can see? So okay, so M is like midpoint of PQ, R is intersection with circle, and now we have to prove PQA R a circle, and M is like midpoint. So what we done till now, like with midpoints?
Reflect D about B about M instead.
What?
Reflect B about M. Then we get a parallelogram.
Yes, but
And
then
that also lies on that circle.
okay, yeah, that's again lie on the like same circle as we discussed before. But yeah, but actually what I want to say is like rather than B, think of something like A because we have to prove with A, and R C because we have thing with C. Like the main objective of our like solution should be A and C, not B. Right? Reflect R. Okay. How and where? No, don't move.
It is not given that R is on omega.
R lie on omega. Wait. Yeah, it's like circumit. Oh, sorry. That typo. Okay, R lie on omega, guys. So, okay, let me explain the question. AD intersect BC at Q, AB intersect CD at P, M is midpoint of PQ, and we intersect MC with omega, and so R, and the intersection is R. Now we have to prove PAR circle. Oh, I made a typo. Where did it happen? So we have to prove this R lie on this circle. Now can you think of like okay, so R lie on circle, then what? Like some obvious angle change or something. Okay, yeah. So actually, okay, I will wait for 2 more minutes to come up with idea. Like I guess everyone should come up with the idea. So like we have this angle theta equal to this, which is like this 180 minus theta. And we have to prove angle ARQ theta. Introduce intersection of wait, how you introduce intersection of APAB?
Reflect A about M.
A about M. Okay. Wait. Yeah, but what does that give us? Like parallelogram. You guys are like on right track, but like not A. Because like this give like same angle condition. This equal to this, which is equal to angle PR. Okay, so like let me say like while like solving the problem, how you guys will think of it. Like what we want to show A PAQ equal to PRQ. Now how we will prove this? Now what we know about PAQ? It's like angle DAB. So like this angle theta is equal to angle DAB, which is actually 180 minus angle BCD. Ah, okay. Now extend and one. Yeah, yes. Mercure, okay. Okay, Mercure point. And Mercure point lie on RAN. Okay. Uh, let's see about. Okay. Okay, so the ideas few people give is like the one we need. So we not reflect B or C, we actually reflect point C. So if you reflect the point C actually, C dash, what we get? This angle is 180 minus theta. And so this is like parallelogram. And this angle is 180 minus theta. So what we get actually is like A, P, C dash, Q cyclic. Yeah, we reflect about M. So like because of that, we get like Cm equal to C dash M. And that's why like C dash Q C P is parallelogram. So do you guys see how A P C dash Q is cyclic? Everyone.
Yeah.
Yes. Okay. And now what we remain to prove? Actually,
We need to prove that R is also in the same circumcircle as C prime and P.
yes. Okay. Yeah, we have to prove like R lie on the circle which is made by like P C dash. Why my C dash is like some weird C dash A Q. So how we will like prove? Like now think about R. What is R actually? How we define R? Now we go like in forward direction. Like now we have to prove about R. So we go from definition. How we define
Use
R? Like,
point.
yes. How?
So we know that.
Huh?
Just a second.
Yeah. Okay. Fine. No problem.
Maybe MP times MQ is equal to MC prime times MR.
Yes. Wait. Repeat once again.
MP times MQ equals MC prime times MR.
Yes. How?
Because C prime MR is collinear.
No. Okay. So what we have is like MR into MC, and you are saying it's equal to MP into MQ. So how we get this? Angles C dash R A equal to angle B. Okay.
I think it will be MR times MC dashed.
Yes. So okay. So we actually like construct C dash as a reflection. So wait. Clear. So actually, the MR into MC. This is like power of M with respect to omega. Okay.
Yeah.
Which is also equal to MR into MC dash because MC equal to MC dash because we just construct the reflection. And now we have to prove is like power of M with respect to omega is like MP square. Right?
Yeah.
Yes. Now, what you guys like? Now you guys can like how you guys will do this. Actually, hmm. Yeah, okay. Someone actually come up with the angle solution. So what we have is like, wait, I guess, yeah. So this like angle ARC, which is equal to angle ADC. So we have this angle equal to this angle, and angle ARC, ADC is just equal to this angle, and why that is so?
ADC is equal to QBA, I guess.
What ADC is equal
QBA.
to QBA? Yes. Now let me count. Angle ARA equal to angle AQ.
Oh yeah, that's a parallelogram, right?
Yeah, this is a parallelogram. So like this is parallel to this is parallel to this. So do you guys got it? So what we get is like, yeah. So this angle is equal to this angle, which is like 180 minus this angle. So if we call this alpha, this is alpha, and this is 180 minus alpha. And now as a QC is parallel to PC dash, we get this is also 180 minus alpha. And so what we get is like, I lack of space. So C dash PA equal to angle C dash RA 180 minus alpha. Can you guys see how we get like proper? So this is alpha, this is alpha, this is 180 minus alpha, and because they are like parallel, we get this is 180 minus alpha. Now we get C dash A R P cyclically. Now similarly, we construct like C dash. Similarly, we do same angle chase in this side. So I don't want to control this diagram, but okay. So if we call this delta, we get not this actually.
Aren't
Yeah.
we done?
Yeah, actually we done because okay, yeah. So we have now we prove R line on circle PC dash A, which give us R is R P Q A C dash cycle. So not only R, we have some special points C dash also cyclic with this. So everyone understand the solution. Another way to finish, okay? Yes. So there is like another way which I was saying, like you guys can prove like this power of m with omega is equal to actually mp into mq, or like mp square by like angle chase. And now then you can just directly use power of point at m, which shows like c dash r mq set. But yeah, that you guys can do. But yeah, so the main motivation for the like problem was like we have midpoint, so we again construct some parallelogram. So this is like always useful. So suppose you have some kind of thing and we have midpoint. So it's always like consider at the back of mind this a dash sometimes useful. Now we always seen this diagram, but sometimes it's hard to see here. But yeah, so like let's keep it back. Like if you have midpoints, you construct some reflection. If you like also particular bisector thing, also this isogonal lemma. So like if you have some two equal angles, then we like always like intersect them to make the cyclicity. Okay, now I guess it's 9. Should I take one more problem on? Could you explain? Nah, I guess you can summarize the whole thing. You can actually do. Okay, actually, I have to submit this solution first. Yeah, I will share the practice problems. Yeah, actually, yeah. So, okay, let me summarize this solution quickly. So, what we have is like M is midpoint. We take R. Now, because we have midpoint, we like it's motivate us to introduce C dash. Now, you guys motivate by like constructing some reflection things, and R also will reflect. But yeah, sometimes we have to C dash is like more obvious because of PowerPoint. So yes. Like it seems vague right now, but like once you start practicing, you like get okay, C dash can be the point. And now what we did is like this angle equal to this angle, which is equal to this angle, and because it's like parallelogram, we get this is equal to this. And so like these two angles are equal. So C dash P A R are set. And by power of point, wait, not power, no. Oh yeah, so like this angle theta is equal to this, which is 180 minus this, which is also this. So angle AP C dash Q is set. So everyone understand the solution and the motivation also. Okay, so let me give like some brief what we did. Yeah. Yeah, I will share this screenshot on group. So okay. Yeah, so here what we discuss, like always we can like take some random point Q or something on like perpendicular bisector, and so like it makes like angle equals or sometimes like length equal. So not just these angles, we also have these angles and side lengths. So like sometimes you come up with some length conditions and we think for that. And once you like done with the construction of Q, the problem just was done for angle chase. Now we have some similar kind of problem, but it's like little tough. So we construct like sometimes not like suppose we give this thing only like angle bisector. So it's obvious like after you practice a lot more question that L is useful. Like it's not like obvious like sometimes not useful, but constructing L, which is like midpoint of R, is always like useful thing to do. Like similarly, if you have some author center thing, the construction of some like this thing, the X touch point or something, some like obvious configuration stuff, you have to consider in mind in order to like be more precise in solving. So yeah, so here we construct L, like consider L, then we get some these things are equal, and so because we have weird like reflection about midpoint, we also get do some weird reflection Z. And so once you get a Z, then it's this angle change and power. Yeah, so this was like really nice question. Okay, if you guys want to know, this was like 18 G2, so like 2018 G2. And G2 and G1s are like IMO P1 levels. So like they are actually hard problems, not too easy problems to like, yeah. So this was there. Then this is like isogonal lemma. Uh, this is useful many times. So like just consider in the mind that if you have P such point and so reflection thing and also this construction. So like if you have these two equal angles, we intersect the two sides. So the thing I am saying properly is like we have some two equal angles, then we always like intersect them and we get some cyclic order. Sometimes it is useful, sometimes not, but it's always beneficial to like consider in back of the mind. And we also have yeah, this solution. This solution is like we construct R, which is I know like the magical point. That's why it's called magical. But now it should be like little bit obvious. Like now you guys can think of like okay, we have some parallelogram thing. This is equal like one parallelogram. So we come up with the new point R, and so. And I guess you guys can try on some M also. So M is like points such that M A P B parallelogram and try to come up with solution. And this was about like if you have some point and midpoint, it's always like better idea to reflect or also reflect on like perpendicular reflection. That's also useful. This circle is not doing. Yeah. Yeah. So like both reflection things are useful. Okay. Yes. Any doubt or anything to say? Anything like you guys like any problem geometry like non-motivational or like you guys didn't understand any motivation?
No, not at all.
Yeah, nice. Okay. Actually, I want to try this question at class, but actually I didn't get. So you guys can try this one. This is like really nice problem. And if some of you like come up with the solution like just share with me. This is like really nice problem, and this is also really nice problem, both of them. So just try for like harder practice. And yeah, today's class question were like not RMO level really. They were like in more plus. So it's not that you didn't get any solution or like no, I guess solution I explained, but any motivation or how can I come up with? It's come up with practice. So like once you start now once you now have an idea of some reflection and how can I construct the new points, now you guys like have more intuition about problem toward the new things. Yes. Anything more? Uh, any doubt or anything about job? Okay. Okay, so there is one handout, but I don't know how useful it will be. But yeah, I will like share like notes and also practice it, and there. Okay, yeah, fine. Yeah, yes, yeah, like construction. Yes, so I guess I don't know. I will share this PDF I got. Like this is like made by me only, but yeah, I will share these problems. Like there are two, three more, and you guys can try them out. Okay, anything more? And yeah, any doubt or any don't understand. How you guys like feel about today's class? Like, was it like I'm a nice? Do you guys get any motivation? Yes. Okay. Yeah. And so yeah, so there are so like few other things about geometry, but yeah, you have to like keep learning and like solving many problems. They're not like always you have to use advanced techniques like inversion or something. The basic angle is radical axis and this is like new point. Now there are few solutions using radical axis to this problem or inversion. Yeah, there is an inversion solution for this problem also. But the Q like point Q solution is like more nicer and beautiful if you say. So like yeah, and as you like just try more problem, you will get take yeah okay yeah we'll see about that more lectures yeah. Yeah, this is also like if you have some weird reflections, then like we always think of the reflections and okay then I guess any if you any no one have any doubt we can actually stop the recordings. Wait, do we have where is the sheets? Oh my god, no one is. Yeah, anyone have any doubt like or some any hard geometry problem or something? Just give me a second. Yes. Okay, just okay, this.